All right, we are picking up with example 3 of Unit 1, Lesson 13 on nth roots. This is a real-world example, and in this example we're going to be approximating radicals. So our problem is a space problem, and it says designers must create satellites that can resist damage from being struck by small particles of dust and rocks. A study showed that the diameter in millimeters d of the hole created in a solar cell by a dust particle traveling with energy k in joules is about d equals 0.926 times the third root or the cube root of k minus 0.169. And we need to estimate the diameter of the hole created by a particle traveling with energy 3.5 joules. So if our energy is variable k, think about where you're going to put the 3.5 in the problem, and then think about what we could do to solve for the diameter of the hole. So what we need to realize is that this 3.5, they're giving that to us. They're giving us the value of k, and we're going to substitute that in for k, and we're just going to plug this number in our calculator and see what the answer is. So let me see, do I have my calculator app open? Okay. I'm going to get off this graph. Clear my home screen. Okay, I'm going to type 0.926. And if you want to do this special root, you can't use the square root button. There's another thing we have to do. I believe it's in the math menu, and it's this number 5. It's x right here. But in order to do that, what I need to do back here first, I believe, is after my 0.926. I think I need to put a parentheses and then start with the root there. So that's a third root, so I'm going to start with 3. Then I'm going to go to my math menu. I'm going to press this option number 5. So that puts the third root in there for you. If you don't have an 84 plus, if you only have the 83 plus, it won't put the 3 up there. But if you have an 84 plus, it will put the 3 there. If you have the 84, it'll just leave the 3 in front, and it'll still say x up here. Our k value is what goes under the square root. That was 3.5, so we're going to type 3.5. Then I need to get out of my square root, not my square root, my cube root. I need to get out of the root by closing the parentheses, and then I'm going to subtract the 0.169. 0.169. Hit enter. Our answer is 1.2369. Let's see what they say on the next screen. We had 1.2369, and they rounded that to 1.237. I guess that's our answer there. So I think they're going to throw up their final solution on this page. So the final answer, what you're going to say is the hole created by a particle traveling with energy of 3.5 joules will have a diameter of approximately 1.237 millimeters. If you want to check that, you would take your answer right here and replace it with the d for the diameter of the hole. We're going to add 0.169 to each side. We get this new number on the left. Then we're going to divide by 0.926, like they say here. This number divided by 0.926 gives us 1.518. If we have the cube root here, we're going to cube both sides. Let me put that up here with my drawing tool. In order to get rid of this cube root, we are going to do each side to the third power. We're going to do 1.518 to the third power. And that gives us a value of 3.498 for k. And you remember that originally they told us k was 3.5. And obviously 3.498 is really close to our original answer of 3.5. Okay, part B of this problem. This time the whole setup is the same. It just says if a hole has a diameter of 2.5 millimeters, estimate the energy with which the particle that made the hole was traveling. So we're going to plug 2.5 in for the d, the diameter. So when we do that, we'll have this problem. The first thing that we're going to do, they don't show any of the steps here. You could just do this on your calculator. Well, you can't really do it on your calculator. There's some steps you got to do. But just following the algebra, the first thing you're going to do is you're going to add 0.169 to each side. So we'd have 2.5 plus 0.169. And then we'd have to, once this is gone, we would have 0.926 times the cube root of k equals this number, whatever that is. We're going to divide by 0.926, so I have to divide this side by 0.926, and then this will be gone from the right side. So the only thing that we have left on the right side now is the cube root of k, and remember to get rid of the cube root of k, we're going to cube each side. So we're going to take this whole amount right here and cube it, and that's going to give us our k amount. That's the energy. And if you type this in your calculator, now you would want to go and dump this number in your calculator, type it the exact same way you see it here, you will get 23.9. So your final answer, what you're going to say, the hole with a diameter of 2.5 millimeters was created by a particle traveling with an energy of 23.9 joules. Okay, here's the problem for you guys to check your progress on. We've got a physics problem this time with a different equation. Pause the video as long as you need, read through the problem, work the problem out on a sheet of paper. When you have your answer, come on back to the video and go to the next slide. And our answer this time is B. For the second part of this problem, go ahead and read through that. When you have your answer, come on back and advance to the next slide. And our answer to part B, how long is the pendulum? If it takes 5 seconds to swing back and forth, the pendulum would be C, 20.3 feet. And that is the end of Unit 1, Lesson 13 on nth roots.